Hello, everybody. We are back with another visual pattern challenge for you. And today I think we have kind of a difficult one. Here is our visual pattern. Here's step one, step two, step three. You can see it's growing pretty rapidly. Your job is to predict how many of these interesting little shapes are in step number four. And then if you can do that, predict how many in step 43 and see if you can write an equation that could be used to predict the number of these things. I'm going to call them diamonds, the number of these diamonds in any step at all. So that's the challenge. If you'd like to accept it, I think you have your work cut out for you today, but pause the video, give it a try, see what happens. All right, so let's see if we can just look at this and try to grasp what's going on here. The first thing I notice is that between step one and step three, it's growing pretty rapidly. So I'm wondering if this is more than just a simple linear pattern. It seems to be getting bigger really fast. And let's see, the thing that visually that jumps out at me right away is that it's got these 2 points hanging off, and they seem to be in common on every one. And then what's left, if I think about the other stuff, is something kind of a more simple shape. So let's think about those two as a constant in this pattern. And then what do we have? Well, we have a row, one row of two, and then we have 2 rows of three, and then we have 3 rows of four. So it seems like in every step, the number of rows gets bigger and the length of the rows gets one bigger as well. In fact, the number of rows is just the step number, right? So this is a row, one row. So step number one row, and it's got 2 in it. So it's like one more than the step number. And you could even think of this as like a rectangle. That's, let's see, how would that be? That would be a rectangle that's the step number times the step number plus 1. So that gives us this, right? The step number would be 2, and the step number plus 1 would be 3 here. So 2 times 3, a 2 by 3 rectangle. Here it'd be 3 by 4. It's step 3. Step plus 1 would be 4, it'd be 3 by 4. So that's what I think is going on in the middle. So we have the step times the step number plus 1, and then we've got these 2 little things to add off the end. Now, we've pretty much made an equation already, and we'll put that in terms of x and y in a minute, but I think we can use this intuition to predict step 4, right? This should just be 4 rows of 5, right? So we'll have a 4 by 5 chunk, and then one here and one here. So that's going to be 4 times 5 is 20 plus 2 more is 22. So I think there are 22 in step number 4. That's my prediction. But let's analyze the numbers and then see if this is going to fit with our ideas for an equation here. So we've got the step number and we've got the number of diamonds. So in step 1, there are 4. In step 2, that's 8. In step 3, that's 12 plus 2 more is 14. And in step 4, we're predicting 22. So let's look at the differences here. 8 minus 4 is 4. 14 minus 8, let me draw that 4 better, is 6. And 22 minus 14, that's 8. So we are not getting a constant number here, which means this is not a linear pattern. So that hunch at the beginning was correct that this is more than a linear pattern. Let's take the difference of the differences though. So 6 minus 4 is 2, 8 minus 6 is 2. Here we're getting a constant. When you get a constant, in that difference of the differences, that means it's a quadratic pattern and x squared is involved somehow. So that's a good place to start. I'm going to go back to this intuition we had at the beginning to actually think about an equation. The step number I'm going to call x. So this is x times the step number plus 1 and then plus another 2. So this part gives that rectangle in the middle, and the plus 2 gives those 2 things hanging off the end there. Okay, so I mean, we could multiply this out and simplify if we wanted to. Let's see what that looks like. That would be x squared. We got an x squared plus x plus 2. Okay, so x squared plus x plus 2. That's interesting. Let's see if we can see that in our pattern in this one, this would be our x squared, and this would be x. They're both the same. X 1 squared is 1, and then x is 1, and then we got plus 2 more. Here we've got an x squared, and then here's the x. Aha, plus the 2 more. Here is the x squared, that's 3 squared, and here's the x. So yeah, that does make sense. X squared plus x plus 2. Either form that you write this equation in, I think works. I kind of like this one because it shows visually what we first saw there, but this one makes sense too. All right, so let's just test this equation to make sure it's actually working out. I think we saw, but I'll do this again here. So x squared plus x plus 1, so that'd be 1 squared plus 1, plus 2, that's going to equal 4. And that's what we have here. How about for step 2? 2 squared plus 2 plus 2, that's 4 plus 4 more, that's 8. And that's how many we have here. How about in step 3? We have 3 squared plus 3 plus 2. That'd be 9, 12, 14, and that's what we got. So this equation does seem to be working. So x squared plus x plus 2 is our equation. So we've gotten pretty far with this one. If you've gotten this far yourself, give yourself a pat on the back for sure. All we have left to do is figure out how many in step 43. So we'll just replace x in our equation with 43. So y equals 43 squared plus another 43 and plus 2. So 43 squared is, let me punch that into my calculator here, 1849 plus 43 and plus 2. So that should be, if I did my button punching correctly, it should be 1,894 of these diamonds in that step 43. Did you come up with that number too? Let me know. Thanks, everybody.